Find a fourth degree polynomial with a leading coefficient of 1 that has the zeros x is equal to 1, x is equal to -2, and x is equal to -4 plus I. Let's recall that on a fourth degree polynomial function we expect to have 4 zeros. And so far we're given 3 of them. But because one of the zeros is complex, we know by the conjugate pairs theorem that its complex conjugate must also be a 0. And this is now the 4th zero. In part A, we're asked to write our answer factored over the complex numbers. And basically what that means is that complex numbers or imaginary numbers are allowed in the factorization. Let's also recall that if we know one of the zeros of the polynomial, then we can create a factor of the polynomial and it'll take on the form x minus whatever that zero was. So because we're given 4 zeros, we can turn each of those into a factor, but those factors will need to be in the form of x minus the 0. So let's begin with the first 0. If 1 is a 0, then x minus 1 must be a factor of the polynomial. If -2 is a 0, then x minus -2 must be a factor of the polynomial. Remember, we're creating each of these factors by looking at x minus the 0. So let's look at this first complex 0, which is -4 plus I, and x minus the 0 of -4 plus I must also be a factor. Notice that we needed to put that complex 0 in parentheses to ensure that we're correctly subtracting the entire 0. And finally, we have the last 0, which is -4 minus I, and its corresponding factor is going to be x minus the 0, which is -4 minus I. Since we've been asked to factor over the complex numbers, that means that it's okay to have imaginary numbers in the factorization. But one thing that we do want to do to clean this up a little bit is to distribute these negatives into these parentheses, and also call minus a -2 positive. So this last step is just a small cleanup step. This will be x plus 2. And then when we distribute the negative into this first complex 0, we'll have x plus 4 minus I, and then x plus 4 plus I. So this is our polynomial written in factored form where it's factored over the complex numbers. Now just a quick note, it does say that we want to have the leading coefficient of +1, and this polynomial will have a +1 leading coefficient since there was no other constant multiple on the front here. So in part B it says to write this polynomial factored but now over the real numbers. And that means basically that we're only allowed to have real coefficients. So we have to do something about these i's. Before we get started, let's just make note of the fact that these two factors are fine. They only contain real coefficients already. But it's these two factors that need some work because those two contain imaginary numbers. And the way that we're going to eliminate these imaginary coefficients is simply to multiply these two factors together. So let's come aside and look at just those two factors, and we'll multiply these together. And we do this using the distributive property, which essentially says to start with the first term, and we'll distribute it into all 3 terms of the second expression. So x times x is x squared, x times 4 is plus 4x, and x times I is plus xi. And now we move to the next term. And we'll distribute that in. 4 times x is plus 4x. 4 times 4 is plus 16. And 4 times I is plus 4i. And now we move to the last term. -I times x is -ix. -I times 4 is -4i. And -I times +i is minus I squared. So now we combine like terms. We only have one x squared term, so that just gets copy-pasted down. And we'll cross it off to indicate that it has been dealt with. And now let's look at the x terms. We have a 4x here and a 4x here, but that's it. 4x plus 4x is 8x. And let's cross those off to indicate that we've dealt with those. Now let's look at the x times I term. We have x times I positive and x times I negative, so those two terms just cancel each other out. Notice also 4i and -4i are going to cancel out. Now we have a constant 16, but also minus I squared. And remember, I squared is equal to -1, so this is minus -1 or plus 1. So we have plus 16 plus 1, which is positive 17. So when we multiply these two factors together, what we end up with is an irreducible quadratic factor that can be used to replace those two factors in the factorization. So now let's rewrite our polynomial, but this time with all real coefficients. And so we have x plus 1, x plus 2 times x squared plus 8x plus 17, which is the irreducible quadratic factor that we got when we multiplied these two together. So now our polynomial is completely factored over the reals, which means that it's factored as far as we can take it if we are restricted to having real coefficients.